All right, let's go ahead and kick things off. Thank you, everybody, for joining today's webinar, where we're going to be sharing some new research from both Forrester as well as Cast AI regarding CPU and memory utilization and GPU and GPU availability and pricing. Can we go to the next slide, please? Awesome. We've got some great speakers today. We've got Tracy Wu, who's a principal analyst at Forrester, and we've got Laurent Gill, who is our co-founder and president here at Cast AI. Next slide, please. Thanks. Today's agenda. So as I mentioned, we're going to be going through the results of the 2025 Kubernetes Benchmark Report, which is our third annual report, as I mentioned earlier, on CPU and GPU utilization, CPU and memory utilization, as well as GPU availability and pricing. We're also going to be going through Tracy's research with Forrester and some of the highlights that she's seeing in utilization as well. And then we've got time left at the end for Q&A. As we're going throughout the presentation today, please feel free to ask questions in real time. We'll be taking a look at those. And if it makes sense, we'll ask those questions live to Tracy and Laurent. If it doesn't, we'll hold it until the Q&A section at the end. Next slide, please. Awesome. So we're going to kick things off. First, we're going to start with a poll. Do you use automation to manage Kubernetes cloud resources? Please go ahead and click on which of these three options fit you and your company best. We'll give everybody about 30 seconds to respond, and then we're going to take a look at the results and then dive in. All right. Thank you for taking the quick poll. So it looks like we've got 48% of folks saying, I never used automation for this aspect of K8s, a very close 36% saying that they're an experienced automation user. And then we've got 17% saying, I'm experienced with automation in dev only. So it's great to see that we have people with experience in automation. It's also great to see folks who don't have experience with automation. We're going to be talking a lot about automation today. I think regardless of whether you haven't used automation before or you are an avid user of automation and think you've got it all covered, I think what you're going to find is we have a very specific way of defining automation at Cast, and you may learn a thing or two in ways that you could be using automation to help drive more value for your team and for your business. So with that, I'm going to hand off to Laurent, who's going to dive into the Kubernetes Cost Benchmark Report results.
Thank you, Joe. So I'll go through the report. Before I show you guys some of those, I want to thank you, the audience, to be here. It's a very special day because it's the first time I have the pleasure and the honor to welcome Tracy in this talk. Tracy is one of the lead researcher at Forrester, and it's always a pleasure to have you here. So thank you, Tracy, for giving us.
Thank you for having me.
Yep. I really appreciate it. That's going to be super cool. In the next few minutes, I'm going to show you some of the results of the benchmark report. And we selected some that are expected, but we also found a lot of unexpected results. And I will go through some of those. And for the audience, feel free to ask questions around those, because I'm going to show you some very surprising. And Tracy have also some very interesting statistics on her side that would foster that discussion. So please, by all means, ask questions as we go through this. The report was made using 2024 data, so until December. On the GPU side, we actually also included January and February of this year. It's a study that was made on more than 2,000 organizations. That means this is not a subjective study, so we haven't asked people to give us their answer to those questions. It is a statistical analysis of a lot of organizations and Kubernetes clusters, containers on AWS, on Azure, and on Google that are true representations of the state of the industry. I mean, 2,000 organizations is a lot of organizations, and you can think of this as it's a lot of millions of CPUs in terms of cloud footprint that has been analyzed from a statistical angle. And so what you see in the next few slides is not conclusion, or it's not assumption. It is a true nature of those clusters as they were connected to our engine. We also selected large applications. Large means we did not consider Kubernetes application that use less than 50 CPUs. Basically the same as saying less than application that use less than 10 machines or 10 VMs, so that it's representative. And we are counting AWS, Google, and Azure in a very similar way. So there is no bias on the cloud. There is no bias on the application itself. And all those come from clusters that are using the standard tool of AWS, of Azure, and of Google. So it's unbiased, it's unfiltered, and it's on more than 2,000 organizations that have connected to Cast AI before any form of optimization or automation that we provide. The first result is expected, but also surprising. I'll tell you why. This is saying the following. On average, out of 100 CPUs that you have in your application, can translate by 100 machines if you want, only 10% of those are effectively used at any given time. Now, this can be up and down. This is an average over the year. But think about this. If you flip this around, it means, on average, us humans, meaning us developers or DevOps engineers, out of 100 machines we have in our account, we only use 10. That means we have a tendency to over provision by 10 times. It's a little bit better with memory, but frankly, it's bad anyway. So it's better in being bad, but it's still bad. But bad in the sense that if you flip the coin and you say, well, out of $100 I spend on AWS, on Azure, or on Google, I only effectively use $10 of those 100. Effectively used means only $10 of my 100 have helped me or helped my application run in CPUs and in memory. CPU being a lot more expensive than memory. That's why I make this in dollars. This is actually worse than last year by 23%. Last year was 13%. This year it's 10%. Last year, the over provisioning was 8 times. This year, it's 10 times. So that's the number we find. This is a true nature and a true representation. I mean, think about this. I'm doing this webinar. I'm using a MacBook Air. I probably use 20% of my CPUs. That's the same. But if this was an average Kubernetes cluster, cloud native cluster on a cloud provider, I would just use 10% of my machine to do this webinar. You see how impactful that is. And you also see, and it gives us a lot of hope that if you can do an over provisioning only of 2x, which is we see sometimes for large clusters, then you effectively would reduce your cost by 5 times. 5 times. That's the impact and the reserve of opportunities to manage this in a more automated way. That's actually how.
Hey, Laurent, we've got a quick question that I think is important. Utilization, yes. Is that requested or actual utilization?
Oh, it's the actual one. It's the actual utilization. It's actually on screen now, so you can see it. That's a great question. What you see on screen is a screenshot. It's a graph and a screenshot. The blue line is the memory request, the CPU requested. It was a great point that you made. So here on this container, this is just one tiny container. This cluster may have 10,000 of those. This container was requesting CPU of 0.3. It means that it tells the cloud provider, hey, I need at least 0.3 to run. It also tells Kubernetes, hey, you have to guarantee that I have that in my account because I need that to run. I think I need that to run. The real number is green, the green side. And these have some average. So you can see the max is 0.16. The average is 0.01. You see the 10x here. That's exactly a representation of the 10x. The difference between the blue and the below, the lines below, is your waste. Effectively, on this cluster, you are paying 0.3, meaning you are telling the cloud, I need 0.3, but you need a lot less. Then this one, because this is an existing user of CastAI, we actually looked at what happened when the user turned on some automation, so some form of automation. In this case, it's a smart agent. So it's an agentic AI framework that goes inside, analyze all the containers, and will adjust memory requested based on real utilization. And as is expected, that's what happened. So here it just means that if you use some form of automation, you drop your memory, your CPU request by a lot. And again, why this is using automation over the human? It's very simple. As human, if we see this, we feel the pain. But if you have 10,000 of those, there's very little thing you can do. And some of those containers are ephemeral. So you may have this 10x for a week, and then the container goes away and there's a new one instead. Then it's already too late to change the past. So you're not going to change it. So there is a reason why the 10x is probably what us human would do. It's just that there are too many of those. You cannot manage them manually. Of course, if you have some form of agent that does it for you, the same way the human would have done, then you get a better number like this. So that is what we see. And this is not that great, but there is a lot of hope to fix it by using some form of automation in that case. But another surprising result is it's not always over provisioning. So we asked the engine if they can look at statistical evolution of this, and is there some cases where there is under provisioning? Under provisioning means your request is too low compared to the true utilization. Now remember, on average, it's too high by 10x. But is it always too high? Because these are average. They are not representation of what is happening because it's an average. And here is what we found. And frankly, this for me was the biggest surprise. The research shows that within a period of 24 hours last year, each container have a 6% chance that they run out of memory. So let's rephrase this. Even though on average, we have a tendency to over provision by 10x, well, sometimes, but the sometimes is frequent because 6% is frequent. It's not small. 6% of the case, your container is going to run out of memory. Now think about this. Why I selected memory is for a very important reason. When your container run out of memory, that's the worst in the Kubernetes world. You cannot make memory up. CPU, it doesn't really matter. It's elastic. Yeah, it's a little bit slow for 6% of the time. Nobody noticed. But memory, you cannot make it up. When you run out of memory, it's called an OOM, out of memory. It kills the container and it may restart. That's the problem with out of memory errors. And 6% is not a small number. If you have 10,000 of those containers, there's a bunch of those that are going to run out of memory within the last 24 hours. On average, that's statistical over all the course of last year. See, I was expecting that number to be 0.5%, not 6%. And this is how it looks like, the same Grafana screenshot. I like Grafana. And here the green is the green line is the real memory used, and the blue line was the memory requested. Now, this is a significant container. It used, it claims or it wants to use 3.5 gig, even though only 2 gig is guaranteed. And again, we did run an agent on this container to see what would happen if, let's say, a smart automation tried to fix it. And this is what happened. So the blue line is going up, meaning the agent says, oh my God, you're running out of memory. I have to adjust memory request to higher. You can see here this is typical of AI engine. There is some adaptation. So it increased immediately to a little bit less than 4.5 gig, then wait a little bit, increase again, wait a little bit, increase again. And you can see this movement until it's relatively stable. But the most important point here is the green line now, it's a line. It's not anymore going up and down as it was here. Why? Because there is no more restart. Because now the container have enough place to run, and therefore it runs smoothly. You see the point. So on 6% on average of containers in any of the cloud providers, you have a chance to run out of memory within the last 24 hours. And it actually happens. And when it happens, it looks like this. And it is so important that when you adjust the number, it is smooth and it runs nicely. What you see here is an application of a Fortune 500. It's a real critical application. This is production. This is not development or staging. That's the impact of it. So summarize the resource utilization. On average, we all over-provision by 10 times for CPU, 5 times for memory. And in some cases, we don't do it enough. That's the drama of Kubernetes today. I have more information on this one. Feel free to ask more questions. But there is also some of the things we found. I call it the habits are hard to change. So this is the evolution of pricing. This is a normalized pricing, so you can see the evolution. Evolution of pricing, this is on AWS for last year, for 12 months, for 3 types of machine. M7, which is a new type of machine that has an AMD processor. M6, which is the generation below, and M5, which is the oldest one. Normally, if all us human would look at this, we would tend to use the new machines, SREs. And so what we expect is that the price of the new machine increase over time as it's being adopted by more and more customers. So that's the first line above. The blue line here is going up. That makes sense. So more people use, there is pressure into it, the price goes up. AWS have a very nice way of doing this. It almost feels like a stock exchange. So it's a market pricing. The price goes up because more people try to use M7. But you would have thought that as M7 increase, the oldest generation, M5, decrease. So people leave the old one to get the new one. And that's not happening. So you see here the price of M5, I would have thought would go down as people use the most popular ones. And the price of M5 was stable as normalized across many regions on AWS. The only one that goes down is the generation below M7. So what this is telling me is the habits are hard to change. Those that are new to the cloud would tend to use M7, and they were probably using M6 before, and so they're switching between M6 and M7 because they want to use the new stuff. And that's why I suppose M6 price goes down from February of last year, and M7 goes up. But the fact that M5 is stable means that us as human, we actually never go back to this. That's the habits are hard to change. We as human may not look back on my applications because they run smoothly. We are missing opportunities to use a better type of machine. And this evolution of pricing is exactly what it tells us. So the habits are hard to change. Yes, M7 is more expensive, but M7 is 50 or 60% faster than M5. So if you use M7, you can drop 2x your M5 for 1x of M7 on average on a big cluster. And yet that's not happening. The last piece I want to show you guys is something new this year for GPUs. The question we ask is, how is the evolution of price of GPU? They're hard to find, they are not always everywhere. And what are the best place to run AI workload? So we look at each cloud provider, and we saw here, we ask the engine, tell me how available are these cloud providers for my favorite GPUs to use. So we use the latest generation A100, V100, and H100. These are NVIDIA. And the statistics says the following. On average for Azure, half of the region of Azure have GPUs. Great. So half don't, but half the region of Azure have GPUs available to use. Google have a similar story, but it's not half anymore. So the A100, well, it's only 1/3 of the Google region that have it. And the V100 and H100 is a little bit better. It's not half, but it's better than the 1/3. But the story on AWS is different. On AWS, just 1/3 for all 3 GPUs. We kind of know that. I mean, we heard in the news, GPUs are hard to find. They are expensive. They're hard to find. You need to reserve them if you find them. Yes, they are hard to find and they are not everywhere. And that's the result by cloud provider. Some of those, I am sure, are strategies that the cloud provider have for themselves. So AWS, I'm sure, the well-managed companies. All these 3 are well-managed. And I'm sure they strategically put GPUs in places where they think people will want them. But the result of the shortage, you can see here, they don't put GPUs everywhere, by a lot, because it's just 1/3 for AWS and half for Azure, and Google is in the middle. But it doesn't mean you cannot find them. It just means that strategically, they're not everywhere. And so if you need GPUs, you need to be careful where you deploy your clusters, because you may not have one in the region where you operate. There's another surprising fact. In fact, this one is my favorite of all the surprising facts. We looked at availability of GPUs, and we did this for one machine called P4D, which is a very popular, expensive and popular machine on AWS. And we look at over 14 months, so from January to February of this year, so it's brand new. And we asked the question to an AI engine. The question was, if you were able to move around, where would you put your AI workload? And we were wondering, is it always the same place? Like, is it a place that is better to do that? Is that changing over time? Does it matter if it changed over time? Does it matter in terms of availability and price? Or it doesn't matter? And here what we found, and this frankly is mind-blowing for me. So here's the answer. And believe me, we look at both availability and price change for millions of small data incremental pricing on AWS for this family. And here's what the story is. In January of last year, if you wanted to run some AI workload, then US West 2A is great. It's not expensive compared to the others all over the world, and you have some there. But between February and May, it's not in US West, it's US East, the other side. And it's not US East 2A, it's US or 1A, it's US East 2B. That is better. Then the period from June to July, it's actually in Japan. That's AP Northeast 1A. That's in Tokyo, in Shimbashi. There's a big data center there. But don't stay there after July, because in August to September, you have to move to Korea. That's AP Northeast 2D. It's in Seoul, in South Korea. But don't stay in South Korea too long, because in October, the best place to run them is actually in US West again. But not the 2A that you had in January. Now it's 2B, probably because 2A is more busy. It's always like this. A is more busy, B is less, and C sometimes is the least. Actually, you can see in December, it's 2C. It's the same place, but it's not the same availability zone. And then in January to February of this year, we're back to Korea, to Seoul in Korea. So you see the story of where to find the best place to run AI workload, it changes a lot. But the impact of the change is massive. So here is the difference of price compared to the average. So here's what it says. If you knew that West 2A was the best place to run and you would be in US West 2A, your costs would have been 10 times cheaper than the average. If in February and May, you knew that you should go to East 2B, your cost would have been 7.7 times cheaper than not moving to 2B, et cetera, et cetera. The average is between 3 and 7. So, and this is not just spot pricing over on demand, it also look at availability, because otherwise the price is low, but there is none. So that doesn't change, that doesn't help you. So the third column is a measurement of availability. What this means is the following. Remember, we talked about automation and how, let's say, a smart entity can help you reduce over provisioning. You saw some example there. It's the same here. If you were having some smart agent that could move around AI workload from region to region, the impact is so wide that a change of cost between 3 times cheaper and 10 times cheaper means to me, it's probably worth it to look at GPU availability and be open-minded in moving your AI workload from place to place. Now, remember, this is for LLM. So Gen AI result usually takes between 3 and 5 seconds. So you add 30 to 50 milliseconds to that, nobody cares. So it's okay to use US East, even though you're in Europe. You just add 50 milliseconds or 70 milliseconds to it. It means it's a rounding error over the time it takes for an LLM, for a Gen AI LLM engine to give you the answer. Maybe not between US East and South Korea, not North. But you see the point, right? It's the fact that one of the things that this is telling us is GPU availability, and therefore spot pricing on GPU changes a lot based on availability of those machines. And if you can move things around, meaning use these spot pricing even for the supposedly impossible to find GPUs, which is a P4D, then the impact on your return of investment to run this on spot instance is so massive that you should think about this. Maybe not between US and Asia, but at least between US and US, or maybe between East Coast of US and somewhere in Europe, if you can use those regions.
Hey, Laurent, we've got a clarifying question for that slide. Is
Yep.
this all for on-demand instances or for spot versus on-demand?
That's a great question. So on-demand price change of a region, we actually have that in the report. So you guys can have a look. On-demand price change just because some countries are more expensive than others, and there are some local taxes. So we included all that. But this is comparing the average on-demand price over the spot price in those places. So it's an apple-to-apple comparison. But yeah, the comparison of on-demand only is mostly linked to taxes, not something else. For those machines, for GPUs. For other machines, taxes is less of an impact, but for GPUs it is. When I say tax, it means the ability to buy a GPU and import into the region and paying the import tax on GPUs. That's what I mean. Oh yeah, this is just to show that it moves. So, and moves a lot over time. Oh yeah, and that's the conclusion of that story is the best place to run AI workload. It never is the same place, depending when you look at it. And looking at it is a good idea because the price difference is so wide that if you were able to move or at least deploy quickly one place, only your LLM, right? Not change your app, but only your LLM. You deploy in one place, you move it around, maybe not every 5 minutes, but maybe every week or every month. Then we see the number is telling us your cost to pay for those will change by a wide number. So that's the conclusion. And that's what the report says. Those are the findings you can see. There are a lot more in the report. The first one was there is a lot of over provisioning, but not always. And memory is always something you have to look at. And unfortunately, on memory, it hurts for 6% of the cases. Habits are hard to find. Habits are hard to change. Everybody should use new machines sometimes, especially that when the price is not too different, but still M5 is extremely popular because the price didn't go down, and that's weird. And the third one is GPUs are not deployed everywhere on all 3 cloud providers, and prices change a lot, even within one cloud provider. The example was AWS, and the price changed based on availability. And if you need those and you can use spot instance and you can move around, guys, it's worth it because your cost will go down by 3x to 10x. That's what the statistics says. Now, I'm super excited to hear Tracy because she has overviews on this from research of Forrester. Forrester is a very, very well-known and prestigious firm. And so I thank you, Tracy, for giving us the time. I can't wait to hear you talking about your findings. Is a very interesting. And then Forrester tend to be extremely enterprise. So meaning usually big deployments, expensive ones, big teams, a lot of resources in these teams. So these companies spend a lot of time and resource to optimize what they do. And that's why I'm very excited to hear Tracy. It's all yours, Tracy.
Great, thank you very much. Yeah, the spot conversation is one that's been really interesting for me to speak with our clients. A lot of them aren't actually very familiar with spot, or they feel uncomfortable doing that. I do try to encourage that, given just the amount of savings that you can get on top of reservations or on top of savings plan, but there's a lot of trickiness behind this. And so being able to get some form of automation or agentic system that can help do that decisioning for you is where I've tended to guide clients towards as they're trying to familiarize themselves with the spot side of things. But that being said, let's just talk about overall highlights. So if we go to the next slide, where is annual cloud spend right now? Now, this is a number that I did not expect to decrease as much as it did. So on average, annual cloud spend was $35 million last year, and it dropped to 22 million. Throughout the years, it has been creeping up slowly, and we had expected that cloud spend to actually drop when it didn't because of the downturn. There was a lot of excitement or fear around cloud costs. And so we thought that there would be massive repatriation or at least decreased cloud spend, and it hadn't. And this year, it really did decrease. And I think that there are a few things that are concerned right now. One of that is that there's just concern around, well, what should we be doing? Should we be putting things in the public cloud? Are there sovereignty issues? Should we be using, different areas like colo providers? There are increased investment within private cloud. So that's created a lot of interest in that space. And so that's why we've seen, it's actually one of our cloud predictions last year was that we would expect to see an increased investment within private cloud and also, but not at the expense of public cloud, but it does look like there has been a bit of trade-off there. So this number as a whole, I'd say is lower. I would actually push this number probably up a few million, just because we have a huge range of organizations that we speak with, both from like very small and low cloud spenders to large enterprise cloud spenders. So the number tends to skew a little bit lower, but in general, the delta between this year and last year is very telling in terms of where people's mindset is in terms of should we be spending in public cloud and should we be doing this massive migration? Now, if we move on to the next slide, 18% though, when we look at where these organizations are, are spending more than $25 million in annual cloud spend. And so what does that mean? If you're spending north of $25 million, that means that as an IT organization, you are getting noticed from the executive team. They are trying to figure out what is going on with 25 million. Why does this keep on creeping up? And so the conversation around cloud efficiency or maximizing the investment of cloud has really come to the forefront. And all of you on the call, I'm sure you're familiar with this. FinOps has been a huge topic, and it's really gotten pushed to the forefront, and which is why you're seeing lots of vendors pop into that space, lots of vendors providing different areas to how to maximize your costs. There's been huge practices around it that have stood up as a result of that. So if we move on to the next slide, reducing cloud spend is a top priority. When you're seeing 18% are spending north of 25 million, this is the conversation that they're having, is that reducing cloud spend tends to be important to very important. Now, my lens is sort of skewed since I talk to a lot of cloud teams. I spend my time within the cloud world. I spend a lot of it within the cost management world. But this is a question I get time and time and time again. I have at least 2 or 3 conversations like this every day where I'm working with organizations to help either doing small things like just standing up a FinOps practice, trying to figure out what tools should we provide, what sort of strategy should we have, what sort of guardrails we should put in place. All of these are huge priorities for organizations out there. Now, if you move on to the next slide, the biggest number is, and we've seen this trend of cloud native and the use of Kubernetes orchestrated platforms increasing year over year over year. And what we have here is that 85% plan to use them within a public cloud environment. They're either using or they plan to use that. So that number is massive. And up until maybe just a few years ago, there wasn't a lot of ability to have visibility into, one, how to allocate that cost and how to manage that cost, how to optimize that cost within a Kubernetes orchestrated environment. We've seen lots of different strategies, different solutions that have popped up into that space to try to manage this influx of usage within using cloud native services, and how do we maximize, how do we make sure that we're managing that investment. And so if we go to the next slide, these tools today are mostly good at some specific low-hanging fruit. So if you talk to a team, and if they aren't already doing waste elimination, doing some sort of right sizing, doing idle resources, eliminating them, deleting them, or optimizing in some way, resource scheduling, monitoring, these are your basic low-hanging fruit that if you are trying to figure out as a FinOps team, what are the things I should be doing? If I'm looking at solution, what are the capabilities that I should be looking for? If they don't have these areas, there is something wrong, and there are major gaps with that solution. So those are when you're thinking about, what should my strategy be? What are the different offerings that I should look at? This is base level. The things that tools are missing that a lot of them don't have, we can see on the next slide, which is really around this ability to manage Kubernetes costs, and not just your general cluster right sizing, but cluster right sizing that's based on their actual pod resource consumption. A lot of solutions right now, they do have some sort of Kubernetes costing capability, but it doesn't get this granular. They don't have this ability to auto-scale pods, horizontally within a cluster. They don't have the ability to do spot optimization. And that's one reason why you see a lot of hesitance from clients, or why I see a lot of that, and why perhaps your organization has some hesitance, is because there isn't a lot of knowledge around how do we manage spot, how do we use them, what specific use cases are we using them for. It's an ephemeral in nature, so therefore that makes it scarier in nature. But there are tools that can help with this. They can help with purchasing for partial cluster usage, doing automated movement of spot VMs to lower price families, being able to identify opportunities for GPU cluster consolidation. But it's very limited in terms of, if you go down the list of I'd say the few thousands of vendors that are out there, and more and more keep on popping up, there are very few that offer this capability. Being able to identify region identification, this was a really compelling slide that Laurent, you had presented here, is their ability to be able to move GPU workloads from region to region. And yes, the data is there, but how can it be consolidated into a single dashboard or done through some sort of automation? Today, most organizations are either pulling together that information themselves, or they're hiring consultancy to do that, or and they're asking them, or they're building that automation internally, which is really not sustainable for most organizations. GPU usage measurements, being able to measure in a few different ways, average uses, dollar wasted memory. This is all granular information that's very difficult to get a hold of. Same thing with intelligent bin packing, being able to revert existing RAs and SPs to spot instances or other commitment deals. Oftentimes, organizations will say, well, we'll use SPs because they're the most free, they have the least amount of commitment, that we don't get the most savings with them, but it works for us. Or they'll choose an RI and they'll say, well, we get more savings, we'll have maybe 20% coverage, which isn't ideal. If you're looking at ideal commitment coverage, it's probably closer to 80 to 85%. But organizations will stay sort of in this comfortable area because they don't want to necessarily overpay for what they're looking at. But the ability to be able to move nimbly between RIs and SPs to spot means that you can have an organization that's getting the most out of their cloud spend efficiency. And so the question is, and if we move to the next slide, is how do we fill these gaps? There is the mainstay, visibility, right sizing, scheduling, turn on and off resources. These are things that are frankly really boring to look at because everyone has it. Everyone should have that. If you aren't doing this in your practice, you should be doing this. And then there's this huge gap where organizations need specific granular optimization for looking at their cloud native services in a Kubernetes environment. And frankly, there's a big missing piece here. And so the question is, and I think that's what we're talking about today, is how do we fill that gap? How do we find that piece? How do we make sure that we're maximizing our efficiency and spend? But I'm gonna open up the table there. I know, Laurent, you and I were going to talk a little bit about some of the questions that are in the chat and some other thoughts that we had.
Thank you, Tracy. And one thing before Joe goes on the question, we do another session, Tracy and I, on the tools and how you fix this with automation. That's what we do for a living, but we'll show you all of those examples one by one. How do you do that for CPU and memory in both directions, right? Over provisioning or under provisioning. Do you do that in real time? And how do you move AI workloads around with some smart decision-making process that says, well, I can do only those and those, I cannot do this one. And then within these constraints, you let an agent do the job. So we'll do another session with that. Our goal here was to show you the state of the internet and what are these big enterprises doing from Tracy's feedback and what they are not doing, which is what Tracy explained to us. Joe, feel free to take all the questions. We're here for you.
Awesome. We have got a bunch of questions. Hold on one second. So first question is there some process to check how much memory and CPU your containers will utilize before deploying microservices on K8s?
Yes. This is a very usually known way of doing for developers. Here's how they do, because we're all human. They'll throw it there. It's called staging. They look around for a few days, maybe a few hours. They will think, it looks like it's this number. And they'll put the number. That's the educated guess. The non-educated guess is the following. These are true stories. Oh, I put 2 because it's always 2. What do you mean it's always 2? Well, it always worked with 2 CPUs. So I just put 2 everywhere. That's another option. And the third option is, well, I always put 1 because it's less than 2 and it's more than 0.5. The short way is nobody really know, right? You can't It's hard to predict the number based on a staging deployment that may not reflect the reality. And it's also hard to do it in production because your application is alive. So you may have more users at night and sorry, the other way. May have less users at night and therefore things are not busy. You may have more at 12 p.m. Therefore things are more busy. So you have to look at all this and decide. My best way of doing it is look at it every second. The human can do this, cannot do this, but the agent can. And then you will know the number because you know that something is watching it and making adjustments as it comes. But the answer of the human side, it's a great guess.
Awesome. Thanks, Laurent. Next question, and this is something that we get a lot when we're talking to organizations about utilizing CAST. How are organizations balancing cost optimization with operational reliability when using Spot instances?
Tracy, you have some example of that? You mentioned Spot.
Yeah, I mean, the easy part of that, well, the easy part about it is just through guess and checking. Like Laurent was saying earlier, you manage the cost through visibility, you measure operational reliability through using some sort of monitoring observability tool and just seeing what breaks and what doesn't. It's not a great answer and it's not a great way to do that. That's why they're using some forms of automation. You know, CAS is a great way of doing that as well. There are other tools, but they're very limited in order to be able to take this. We need to manage costs, but also not break whatever environment that we have. And so that's sort of the crux of the issue here is why lots of organizations have been really hesitant to invest within Spot instances because it's really difficult. They're often using multiple tools to be able to provide some resilience and operational resilience as well as managing costs.
Yeah, we see the same, Tracy. Though the way we see it is like this. Well, if you have a Spot interruption, it's a problem because these machines will disappear. What you need to do? Well, you need to replace them in a hurry. The question is then, but what you're replacing is with what? Like, remember this slide where I showed the pricing of M5 is constant? Well, it's because the human will replace it by the same machine. Well, the same machine is under pressure. You can't do that. So you have to look around and find a better one. Humans can probably do it once a day, maybe twice a day. In our case, it's an agent that does it and does it every second. And therefore, if one family of Spot has price pressure, usually we know this in advance because we use some machine learning techniques that give us a great window in advance to that. Then we will proactively change them and replace them by the next best one, according to what the data is telling us. Human will do the same. Here, it's just something that does it every second. And yeah, yes, when you see it, and as Tracy said, there are other tools that do this. When you see this and you see that, oh, there is an agent that does it now, and it does it every second, so I don't need to do it once a day. That gives you a lot more confidence that, oh, so I can use Spot instance now in production. And then we have users that, I talk Fortune 500, that use Spot in 85% of their compute cost in production. But they were not doing that before. They realized that, oh, so if someone is doing it for me, then it's okay then, because someone is making sure there's no impact in production. That someone is an agent. That's our experience.
Laurent, follow-up question. Would you be able to support EKS node groups that allow mixing instance types?
Yeah, except, yes. In fact, that's the concept, but it's I think it's smarter than this. We go away of node group. Think of this as it's almost like each instance it is its own node group. And so the agent is able to select any within the 600 type of machines you have on AWS. Any of those will be carefully studied and handpicked by the agent to replace one over another. This has constraints, right? You can tell an agent, well, I'm okay to use any AMD processor, but I need at least that amount of memory. Or I only want Intel, that happens. Or I'm okay to use either Intel or Graviton or AMD. Go figure this out for me, please. So you build the constraints like this. It's kind of the borders. And within the borders, the agent will always try to optimize as much as it can based on the weak signals of spot pressure. That's how that would work. The human would do the same. That I want to say, there's no magic into it. Like it all makes sense. Like I'm telling this in English. It's a story because that's exactly how it is. It's just that instead of the human doing it, it's an agent that does it. And because it's automated, then you can do it very often. That's the idea.
And then another question is, what specific automation techniques have proven most effective for optimizing K8's cost?
Oh, that's a really good question. And so, because we wondered that too, and Tracy, I'll ask you your opinion there after. So, when we started this journey almost 5 years ago, and 2 of the 5 years we were just building things. So we have 3 years of data behind us, and in the beginning we felt, oh, that's it. We found the solution. Let's have something that smartly select machines. But then we kept adding features to that. And these features, some of them are what I call orthogonal, meaning they are independent from each other. And then we felt in the beginning, there must be some heuristics that says, do this before doing that. And because it sounds normal, like reduce the size, then change the node. And then at the end, we decided to do differently. We said, dear agent, here are the 5 things you can do. Go figure this out for me. And when you do it this way, then sometimes, especially in the terms of spot instance, sometimes you are going to over provision because that machine happened to be cheaper than one that is smaller, but where the spot price is higher. So you see when you look at the curve and you look at the minimum cost, there are many minimums. And there is a minimum for those scenarios, there's a minimum for those scenarios. It's hard to be deterministic because you have to look at all of them. This is where agentic framework, or let's say nonlinear techniques like ML or AI, works very nicely, because then you just told the engine, you can do all of these things, 5 or 6 of those. Here are the constraints, but I don't like graviton, for example, or I really like graviton. That's the other side. And then you let it down. Let the agent do its thing, thinking that it has all these options to play with. So that's the best way that's the way we felt or we saw is give the best return. It's very non-linear, meaning there is no predictability to it. You don't know in advance what the engine will do. It really is looking at all of these things, plus the pricing of the neighbors. And based on all of these things, it makes a decision every second. Tracy, do you have some?
Yeah, it's difficult to implement automation, period. When I talk to organizations, like, what are you automating? It's not looking at, say, the automation of Kubernetes costs, which is why the question comes up. Because when I've talked to organizations, where's their automation? It's in very low-hanging fruit. It's in, deletion, maybe unattached volumes. That's where the automation is. I have been hearing more and more organizations that have been doing automation, or actually automated cluster right sizing is probably like the most common one. Generally, it's not in prod environments. It's generally in your test environments, but actually I've been talking to some clients that have been starting to do that in their prod environments as well, which is really surprising to me. But in order for a FinOps practice to start to be more and more mature and to be able to offload some of this, very human intensive, manual intensive techniques, there does need to be some automation injected in there. So as far as, what's most used is the automated cluster right sizing. There is obviously a lot of other techniques out here, things that Laurent had talked about, the automated workload placement. That could be huge and could be huge savings for you.
Thank you, Tracy.
Awesome. Thanks, Tracy. Question from Ming. Would you recommend not to set limits on resources, for example, CPUs and RAM?
Yes, It's very controversial. I hate limits with passion. Don't put any limits. Let the engine figure this out. You know, we tell now, Tracy mentioned it, is we tell our users, don't even bother with requests, CPU requests, memory requests, CPU limits, memory limits. Anyway, in 30 minutes, it will be changed. And it will be changed by something that is so much more accurate, because if it changes again, it will also be changed also again. So this, I know it's controversial because it goes a little bit against the idea of, well, you know, these are my containers. I'm supposed to know them better than because I created them as a developer. Here we're saying, yeah, but anyway, it's wrong. So just let it go and don't mind about it, because in 30 minutes or less or more or whenever it will be fixed. And the engine knows these things. So it says, like, we have things like only change them if the impact is more than 10%. So you see, you can put some limits there, some filters. So it doesn't do this all the time, but it's a kind of a nice line, like you saw for memory. Yeah, like you actually saw, right? Memory went up earlier, went up a little bit, and then that's it. You got it. It stops. So that's how we find. So please, no limits. It's evil. It's artificial. We have an airline as a client that had a lot of limits. The minute we eliminated the limits, they said, oh my God, everything changed. They were constrained. They didn't know they were constrained. They could see it in Datadog. I mean, like there is a lot of nice observability that shows these things. They kind of see that orange line that says the limit is being hit often, but they didn't know what happened if you let it go, right? And when they let it go, it finally expressed itself to the right amount. It's weird to say it, but it's exactly what happened. It expressed it. It went up. And it went up nicely, and then it became more stable. That's so no limits, please. I know it's controversial. No limits, no requests. Just put something by default. Let something else tell you by measuring it what it should be.
Well, Laurent has made his point of view clear. Tracy, I see you nodding your head.
Yep, that's a big recommendation I've had, that don't put limits on, especially on your memory. That can create unoptimal right sizing recommendations, and you should just see where the chips lie, then make your decision before. I mean, if you especially like constrain your memory, you're only getting a specific level of recommendations, and you may be missing on more optimal instances to choose from.
Yep.
Awesome.
And by the way, so the only limit we have is a limit of budget, because if you have memory leak, you have a stopgap. So it's a budget limit. It's a dollar number. It's not a gigabyte number.
Gotcha. We're up on time, so we're going to wrap this up in respect of everybody's time with one more question. This is from Pathu, and I'm sorry if I pronounced that incorrectly. Can CAS dynamically manage Fargate serverless resources alongside traditional K8s nodes that reduce costs?
Yeah, Fargate is a great product. I'd say differently. If you use agents, they will make that decision for you, and therefore using Fargate or using regular node becomes irrelevant, because someone else will make that decision. Most of the time, what we see is that Fargate gets eliminated and gets replaced by nodes, because essentially what happened when you use an agent is that each node it's almost the same as being serverless, because someone else is making that decision of what machine you should use, and therefore, yeah, who cares? That's the right one anyway, whether it's a Fargate or a regular node. So the best way to answer is Fargate is an unnecessary constraint that you don't really need if you use some form of automation that will select the best machine for you. If you don't use automation, Fargate is a great product.
Thank you. And we were going to wrap up, but have more questions coming in, so we'll just keep going until everybody's done. Next question is, when we use AI agents to increase memory requests based on usage, what if worker node doesn't have available memory as the node is totally packed?
That's a great question.
Good question.
Yes. This is why automation is so important. It's okay because the agent will say, oh my God, I don't have space anymore. I'm going to spin a new machine. It will make that decision before you even notice that you're running out of stuff. But it goes deeper than this. Here's it. Oh my God, this machine have no more space for that container that runs on that machine. Well, there is another machine that have space. Oh, let's move that thing to that machine instead. But it goes so fast that by the time the memory pressure is being felt, it has moved already. You see how cool agent is. Yep.
Awesome. Thank you. Well, we'll wrap up. Like I said, we're a little bit over time right now. Thank you, everybody who's hung on until the end. Quick flag for folks. We will send out a recording of the webinar if it's helpful for you. So expect that. In addition to that, Laurent and maybe even Tracy. I know Laurent is going to be at KubeCon and at GCN, Google Cloud Next, the next 2 weeks. If you're interested in seeing automation live in action, feel free to drop by our booth. We'll be at both shows. And we'll have a number of webinars coming up in the next couple of weeks and months. So stay tuned for more information. And we've got a lot more research-based data that's going to be coming out, shedding more insight into things like which LLMs are best based on price performance, which we know is something that people are interested in. So thank you again for joining. Talk with everybody again soon. Laurent?
Yeah, I was going to say at KubeCon in London next week, we have some really cool things to show on GPUs. Some of the things we talked about, the best place to find GPUs. You can see it working in our live at KubeCon.
Yes, and we're also going to be doing a demo of live migration, which moves stateful workloads, which is very, very exciting. A lot of folks have been interested in that. So if you want to see that in action, please drop by. Thank you again to everybody for joining, and big thanks to Tracy for joining us here today as well. We really appreciate
My
it.
pleasure.
Thank you.
Tracy.
All right. Take care.
Everyone.
Bye.